Lesson 26, Enumerations. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Enumerations allow programmers to define their own data types, which typically take on a small number of values. For example, if we are writing a card game, we could define the integer values 0 through 3 to represent the card suits like this. Alternatively, we can define these values more properly using an enumeration. Here we define the enumeration type card suit with the values clubs, diamonds, hearts, and spades. The capital E is used to signal that the type is an enumeration, and the KE is used to signal that these values are constant values for an enumerated type. This is just some of my own Hungarian notation. Making the enumeration declaration as shown sets the values to be 0 through 3 by default. Most of the time this default behavior will be sufficient. If we do not want the default behavior, enumerations offer numerous options for defining the values of the constants. For instance, we can define the values to run from 4 to 7 by defining clubs to have the value 4. We can also define hearts to have the value 10 so that we get clubs equals 4, diamonds equals 5, hearts equals 10, and spades equals 11. We can define all the values individually, but any value that is not specified takes the value of the previous entry plus 1. Lastly, we remark that we can define enumeration values in terms of the prior enumeration values. Here we define the first value as n, and the remaining values as powers of n. Using this, we can change the value of n at any time and generate a new sequence of powers without having to change all the values. Enumerations are integers, but they also define their own type as well. Here we define an instance of our color type and give it the value of blue or 1. In this line we declare an int and set it equal to the value of my color. Notice that we did not need to use the color conversion operator on the color type since the conversion is automatic. However, when we convert back from an int to a color, we do need to specify the conversion or we will get a compilation error. In general, we should not expect the conversion from an int to an enumeration to be well defined outside of the defined range. In the version of Visual C++ that I'm using, enumerations are always held in an int type. However, we should never count on such behavior. Finally, we remark that we can use enumerations to define a set of constant values with no associated type. In this example, the enumeration defines x as 0 and y as 1. Then we can use these values to access the coordinates of our point in a more readable manner. This concludes the lesson.